Hi everyone, again welcome to the LPS class. We are going to continue our lecture on tickle. If you remember, in the last lecture we talked about the TK predominantly. We completed the TK. We gave some more um, advanced tickle processes, basically as to how one can load in tickle as a .sos and call tickle functions from anywhere, things like that we talked about. Today we are going to take another step in that direction, but mainly we are going to talk about tickle in Synopsys tools. These are the tools that you use for your labs, and also in real world you'll be using a lot. And Synopsys has actually modified tickle a little bit for the better. So we will be learning about how to use tickle in Synopsys tools and what kind of support that they provide, because tickle is not only their language, but language of choice, but actually it has a lot of good things basically. So today we will be talking mostly about the tickle in Synopsys tools, which is mostly an extension of the existing tickle. So I will be talking about a lot of the concepts that we already covered, just to reinforce so that you also know what it is. So number one thing, as with any other tickle, we have a number of variables. The variable names are mostly like if they are the scalar names, basically it can you can simply say any name it can become a variable name, and you can assign a value to that variable by using the set command. So simply like set a1 will be same as a equal to 1, or a will have a value of 1. And then these variables, these values can be either integer or floating, and then we will soon see other variable extensions. These are some of the things that we already saw in the very first lecture of tickle. And then one of the key concepts that we also talked about was the variable substitution. That's also valid. So once you have this, and then now you can select say set the $a, so that b will also be equal to 1. So those are the things basically that you can do, and other ones like the various other functions and things like that are also supported, like incremental or additions, and whether the info exists kind of things. Basically info exists is essentially that is one thing which returns if the variable is true. Info exists, it returns a 1 if the variable exists, and if it does not exist, it returns a 0. And then you can also have info vars, and here you can give some wildcard, say x star, and this returns all the variables beginning with x. And then the precision rules are very similar to the regular tickle rules. That means that when you start with an integer, if and then as you go to further operations, maybe like 2, this result stays as an integer, and then you again divide by 2.0. Now this becomes a float. So answer will be 1.0. So and then if you use the float as the first one, the result will be a float. So those kind of things basically need to be aware of. Then one thing that Synopsys provides is also set of predefined variables. One example is the env. So env is a variable that contains all the environmental variables. So we can use commands like array names env. This command will print out the list. It contains elements, element names that correspond to the name of the environment variables. And then to show like a particular environment variable within that, we can also use an echo command. Echo $env home will print out whatever the value that is set as home. And Synopsys also provides a predefined command called getEnv. So the getEnv command is very simple. Basically, getEnv and then the variable name, and then it dumps that particular variable. So the home has whatever it is that gets dumped out. So this is the nifty command that you can use. And now let's go into script. Basically, what is a script? The script is nothing but it's a tickle. So it has tickle commands and Synopsys commands. So these are all like grouped together, and so you can run like some Synopsys command to get some data and then process it through using your regular tickle commands, and then also like apply that back into like the Synopsys tool using the Synopsys command. So that becomes part of the script. And along with the commands, scripts essentially, like I mean you know that already, the hash, if you use it, that's for comments, and this can come anywhere in the line, and the only thing is after the hash everything in that line will be treated as a comment. The only exception is if you are extending the comment using the backslash arrow. When you use the backslash arrow, even the next line, whatever it is, that's treated as a comment. As you know, this is the continuation character, and basically like, it will be this, and any kind of preceding character will be replaced with nothing. So this has a new line next to it, that will be replaced with just a blank, and that's why this line will be then continuous with the next one. And how do we run a script? We use the command called source. So for example, source my.tickle. My.tickle can be a script that contains all these tickle commands and the Synopsys commands, and we simply do a source to run the script. So once you do the source, you can redirect using greater than symbol. So this is all the standard ones that we already saw these things. Now let's go to the next one, which is the data types. As we have seen in the regular, even Synopsys also supports the three basic types of data, which are strings, array, and list. The string is nothing but a sequence of characters. and string can be within quotes. Basically, you can embed strings within quotes, or you can have like just generic strings of just some letters. The strings are usually operated on by a string command. So a string command takes many arguments essentially. So for example, string, and then we can say compare. Here we give the first string and then the second string. So it compares these two, and if they are same, it generates a 1, otherwise it generates a 0. And then string to upper, and then string name. This will convert the string from lowercase to uppercase. So similarly, there are many operations that are possible. The main ones are format, regex, reg sub, which is essentially it uses a regular expression to do a substitution. Also, you can do scan, like a string scan or whatever. And then string provides a set of string manipulation functions, and then string subst, subst, which is for substitutions. So this will be a pure substitution. A reg sub will be based on a regular expression. It can do a substitution. So these are the commands that Synopsys will support. Let's do lists. The list is nothing but an ordered group of elements. So it is usually we enclose it in the square bracket. And we can also use a list command to create a list. So list and then set of elements will be turned into a list. And you know, like I mean, the command substitution, the square bracket command substitution. And then I also think that you remember in Tickle there are grouping. Basically, there is a loose grouping, all the with the braces, and then more strict grouping with the quotes. Actually, it may be like reverse, but the main difference is that here, when you have like a variable $x, it does the variable substitution, whereas here it does not do any substitution. They are preserved as is. So this is more strict, and this is more loose. Okay. So based on that, I mean, you can actually group the list elements. So if you group it here, anything under the inside the brace is treated as one object in the list, and then the others will be separated out. Also, a list has index, it is L index. You can do L index and then give a number and then to access any of the elements, and it usually it starts with 0 and then it goes to end. So L index end will give the last element, L index 0 will give the first element. So these things, they don't change. Other list operations are concat, join, L append, L index that I mentioned, L insert, then length or L length, L range. L range is also like it's a very useful operator. It's basically it extracts the elements in a list within a given range. L replace, L search, L sort, and split. We went in much more details when we covered. I think like pretty much you can use that way. So the tickle interpreter within the Synopsys tool can work with all these different setups. So now we come to the arrays. There is this element here. So array is in Tickle, it uses the associative array. We know that. Basically, the index doesn't matter. It can be a real number, it can be an integer, it can be a string, whichever one that we can use. So typically an array name will be it's an array name followed by element name. And usually the arrays will have a two-dimensional lookup table. Basically, like one is the index and then another one is the value. So it is like a key value pair. Almost think of it that way. Now Tickle also supports the EXPR, so you can use the EXPR as well for evaluating any expression. So the array commands are typically like array and then similar to the list commands. And I have put a question mark here. There is a fourth data type, which is what makes Synopsys tools very special. We will talk about that towards the end of this lecture. This is called collection. So collection is a data type in Synopsys tools. You can actually use this, and it is a very useful data type. It's kind of a list, but it is even more advanced than a list. We will look at it as to how to use it and how actually it's being used today. So operators essentially, like I mean, this mainly goes back to that what I was mentioning regarding the expressions. Expressions are given by EXPR, and then you can have like one argument which is enclosed in the braces. So inside that you can have like a slash b times c plus d, whatever you want. So maybe these are all vectors. Okay, so you have the tall substitution as well. So the operators essentially, like I mean, that you can use within the EXPR command are addition, subtraction, multiplication, division, less than, greater than. This is basically a shift operator where it shifts the value to the left by so many bits. So if you say like A, B, A, it shifts B the number of bits as to A. So if A is 2, it shifts left by 2, and this is a shift right operator, and this is the equal to as a logical operation and not equal to as a logical operation. These are also so these are relational operations rather, but these are bitwise and this is bitwise XOR, bitwise OR, and this is a conditional operator where if A is non-zero, then take B, otherwise take C. So if you say like set X A question mark B C, if A is 1, then X is B. If A is 0, then X is C. Okay. So all the other operators basically you can also use in logical operations instead of bitwise, and the logical operations typically is used inside some control flow structure. So let's see like what are the control flow structures in the Synopsys tickle. So number one is the if else if else. Here you don't have to have both these things, it can just be if. So if has two arguments, one is the expression and then the second argument is the script, and you can see that I'm putting in braces so that they can work. They are grouped as 1 and 2. In an else if case we specify the expression, say expression 1, and then you execute script 1 else if, and then we can give expression 2 and then script 2, and then finally else, and then just script 3. So you can see that actually like it can flow nicely with all the other clauses here. So when the if command evaluates the expression, if it is if the expression result is not a 0, then the script is executed. If it is 0, then it just goes to the next one. And this else if can continue on and on and on. Now the while command. So quick question: how many arguments do you think it takes? So the while command has two arguments, just similar to the barebone if command. It's a while and then condition or an expression and then body. Body is just a script which executes. So these are the two arguments for while. How about for? For is something that we studied also. How many arguments do you think a for has? For is also another way of looping structure. So if you look at for has actually three arguments, actually four arguments. So the first argument is the initial expression, and then the second one is the termination. The third one is a re-init expression. So what does this do? We'll talk about that, and then finally the body or the script itself. So the re-init expression is basically like from initial to the termination, how to go about doing that. So in a simple case, like you can say like initial can be set x 0, and then the termination condition can be $x less than or equal to 10, and then where the re-init expression will be increment x, increment x, and then you can have the body. So that particular loop will be repeated 10 times. Now comes for each. How many arguments do you think for each takes? So this one 1 2 3 4. For command takes 4. This takes 3. How many do you think for each takes? Actually, for each takes actually 3 arguments. Actually, like this is 2 arguments. While it takes 2 arguments, for takes 4, and for each takes 3. So what are the 3 arguments does it take? So it takes a variable then the input list, and then the body. So it picks up one variable at a time from the list and then runs the body for each one of them. Now there are two other, actually three other controls, three other control flow commands, which can actually cause changes in the way the flow is being run. So one such command is break. The break command will cause the innermost loop to terminate as soon as it hits the break. And these can be used to actually change the flow for each and while. Now the next one is the continue command. The continue command actually causes the innermost innermost loop to stop, but it continues from where it left off. It won't terminate the whole thing. So it causes the current iterations of the innermost loop to terminate, but the next iteration will still continue. So continue is kind of its more safer kind of a command compared to break, but you may have situations where you use one, you can only use one or the other. They're not interchangeable, and sometimes like the break won't fit in where the continue fits in, and vice versa. Now the last one is the switch command. The switch command, how many arguments does it take? Actually, believe it or not, it takes only two arguments. So the switch has a variable and a whole bunch of value and then script. This entire thing is actually enclosed within one brace. So you can almost say that basically for given variable, if it is of one pattern, then do one script. If it is of a different pattern, then do a second script. Things like that, and it progresses. I mean, until you have no more patterns and scripts. The switch command also has three options that we didn't talk about. It can be exact match, or a globe match. GLOB. This is not to be confused with the glob operator. This is glob match is essentially it's a kind of a loose match, and then finally a regex basically. So these are three different options that you can provide for the switch command. Now let's talk about the basic file commands. So before we talk about these additional commands, basically we have cd and pwd. I think you guys know that cd stands for the change directory, and then pwd is the present working directory. Those are pretty much the same, and you can use that inside Synopsys pickle command interpreter. And now let's look at the file commands, and there are two of them basically, like meaning like we can use two different types of options here, either file or glob. And glob, you know, that basically matches the regular expressions in this context. So the file commands are directory name to get the directory part of the file name, and then you can also do file exists and then given a file name, which returns 1 if the name exists or 0 if it doesn't exist. File extension is gives the extension part of the file. For example, foo.text, it returns the text. And then is directory is a command that returns 1 if the file name specified is a directory, and 0 otherwise. And is file also works the same way. It returns 1 if the name next to it is actually a file that exists. Otherwise, it returns a 0. These are all like file testing commands. Then readable is another one, which is returned if the permissions are set such that the file can be readable. File is readable. And then the root name is another one, which is gives the root part of the file name. Size gives the size of file name in bytes. And then file tail file name will return the file name from the path string. And then you also have like writable, which is basically returns 1 if it is writable or 0 otherwise. Now the globe is actually, like I put it towards the end, basically the globe matching is something that we talked about. In this context, it actually returns the files. It's a glob command. It's mainly for pattern matching and reporting files. And glob, you can say like star.verilog and then star.text. This will return a collection of Verilog and text files. Okay, so far so good. Let's continue on. So file access commands essentially, which is how can you open a file and access. Actually, the first command is file open command, or just called open. Here you can say like what is the file and then what is access mode. The access mode can be R, which is just read only. R plus, it is used for reading and writing, and the W, it's open only for writing. W plus is open for reading and writing, and if the file exists, it truncates it. Otherwise, it will create that file. Then A is open the file for writing only, and then the new data is appended to the file. So the existing data is kept, and then the new data is just getting appended to the file. Here the only requirement is that the file name should exist. It won't create that particular file. And A plus is the same thing, only for now you can use it for reading and writing. And here if the file does not exist, it creates the file, and then the new data is also like appended to the file, similar to the previous command. And to close a file, we just specify the close command. The close followed by a file ID, $file ID will close that particular file. Then we also have another command called flush command. Literally it means flushing. So but the way that it is, the flushing happens is whatever stored in the buffer gets written into that file at this point. Usually when it exits, that's when it gets written out. In this case, when you issue the flush command, at that point it gets written out into the main file. So no buffer is being kept. Now we have other two commands also to get information from the file or put something into the file. These are just the gets and puts. So the gets command essentially with, given the file ID and the variable, it reads line by line into that. The put command essentially like whatever is specified in the line gets put into the file. And also there are two other commands for non-sequential file access, meaning you can go directly to middle of the file and then start reading from that. And those commands are seek and tell. The tell command essentially it's used to obtain the current position of the pointer in the file, whereas a seek command will just given an offset, it goes to that particular location to see what is there. Now we come to much more interesting stuff, which is procedure. So as we saw, actually we can define procedures, and then we can run these procedures instead of the native commands. And then the main command that creates a table procedure is proc. So and then proc has 3 more arguments. It's the name of the proc, arguments, and then the body. So we saw like a lot of these things about procedures in the previous lecture. And we also talked about the variable scope in the context of the tickle, in an overall tickle. And this is essentially the variable scope determines like how to access the variable. So if you want to preserve the scope from a global variable into the procedure, we use the keyword global, so that that particular variable is visible inside the environment or inside the procedure. Now if you want to pass a procedure, pass a variable back to the calling process and without actually passing it as a result string, we can do that using for, and we can also do upscript to upload the script itself. These are some of the commands that we saw already. And we can also specify defaults for the arguments just right next to it as a single element essentially, and then tools will take it. Now coming to the variable number of arguments, this is specified as args in the procedure. So if one of the arguments is just called args, then tickle treats this as a variable number of arguments, so it will keep reading that $args until it is fully exhausted. And arrays in procedures, you can use arrays inside procedures. Basically, again, the scope needs to be determined, and then you can assign a scope, and then it's quite pervasive at that time. And arrays can also be added into procedures. Now extension, this procedure extension essentially. So Synopsys actually supports some built-in features that can actually enhance the whole Jekyll script writing. It's no longer feels like a script, but it's a full-blown program. So two of such commands are define proc attributes, proc name, and then optionally an info text. Or the second one is parse proc arguments, which has the dash arguments key with the argument list, and then there's a result array which generates the result for this. So the advantages of using these scripts, the define script and the parse script, is that when somebody requests a help on this command, it automatically produces a help essentially. So the define proc command essentially takes, as I said, proc name. It can have some information, textual information with dash info. There are other things which are not very relevant, which is the command group, hide body, hidden, permanent, and don't abbreviate. So I haven't put those additional options. Now the next one is the parse proc arguments. The parse proc arguments has a arg list as one of the arguments, and then a result array. So the results array will contain the parsed arguments essentially. So that's stored in the result array, and then the arg list is essentially a list of arguments that needs to be passed to the procedure. The reason why we use these two commands are mainly so that it makes the procedure more readable, and also it gives a consistent messaging around that proc. The define proc commands also goes with the define proc attributes command that actually gives more information about the all the attributes for the arguments. The parse proc arguments command essentially that if you don't have this, the particular script will not respond to the dash help. You can make it work by using a help procedure name and then minus verbose, but if you want to get the procedure added, you need to define the parse proc arguments. Then once we define, how do we display the procedures? For that we have several commands. We can have info args, info body, so these are some of the commands that we can use in a procedure. So now we come to the collection, which is one other data structure which is unique to Synopsys. The collections are a set of similar type of objects. You can have collection of actually multiple type also, say with attribute, say like nets into a collection, all the cells into a collection, and then you can have a single collection which contains both nets and cells, but they are all grouped separately. So if you have a name called X in the nets and corresponding X in the name cells, they both are separate first of all inside the array itself, and then we can separately destroy one of them if the other one needs to be more prominent. So if you remove any objects, it calls for like cell. So if you remove X, it can be either cell or net, and if it removes it from the cells, the net X is still retained inside the collection. So other important thing to note about collections is collections are memoryless. So it is created when at least one element gets added, and it is destroyed automatically when the last element is removed. So by itself it does not have any kind of bearing on what we do. And for creating collections there are two commands. One is get. Any get star is a typical command for creating collections, and then all underscore star is also another command. So if you want to display objects in a collection, we use query objects command, and for selecting objects from a collection, again filter expression is one, attributes so to select an object from a collection we can use a filter option or filter collection command. So this one is like with filter and then a whole bunch of attributes. Now how do we add and remove objects from a collection? We already saw like how to add the first element using the get or actually the set commands. But for adding and removing objects from a collection we have to use these two commands, either add to collection or remove from collection. So these are preset commands basically which will help add new objects into the collection or remove the existing ones. And as I said, basically like when the last element is removed, this array ceases to exist, this collection ceases to exist, and basically it's completely destroyed. So I mentioned earlier that the collections are very versatile, and it is probably like the best thing happened here. So to compare two collections, we use the compare collections, and then if you want to iterate over a collection, we use for each in collection. You see basically the common theme is the collections becoming more and more. And to copy collection, basically we just use the copy command or copy underscore collection command. For each collection also has just two arguments. and then to copy the collection, use the copy collection command, and the extracting objects should be is using the query objects command. So I think this pretty much is the overview of how we can use Tickle in Synopsys tool. I hope this is useful. We'll probably go through some examples in the next lecture. Okay. Thank you. Bye bye. Hey Sandeep. Hey Sandeep.